Chapter 2, Section 1, States of Matter. It's a bitter cold January afternoon. You're practicing ice hockey moves on a frozen pond. Relaxing later, you close your eyes and recall that the pond in July when you and your friends jumped into the refreshing water on a scorching hot day. Was the water in July made of the same water you skated on this afternoon? Perhaps, but you're absolutely certain that solid water and liquid water do not look or feel the same. Just imagine trying to swim in an ice-covered pond in January or playing hockey on liquid water in July. Your everyday world is full of substances that can be classified as solids, liquids, or gases. Solids, liquids, and gases may be in elements, compounds, or mixtures. Gold is an element. Water is a compound you've seen both as a solid and a liquid. Air is a mixture of gases. Although it's easy to list examples of these three states of matter, defining them is more difficult. To define solids, liquids, and gases, you need to examine their properties. Their familiar states of matter are defined not by what they are made of, but mainly by whether or not they hold their volume or shape. Solids. What would happen if you were to pick up a solid object such as a pen or a comb and move it from place to place around the room? What would you observe? Would the object change in size or shape as you moved it? Would a pen become larger if you put it in a bowl? Would a comb be flatter if you placed it on a table? Of course not. A solid has a definite shape and a definite volume. If your pen has a cylindrical shape and a volume of 6 cubic centimeters, then it will keep that shape and volume in any position and in any container. Particles in a solid. The particles that make up a solid are packed very closely together. In addition, each particle is tightly fixed in one position. This fixed, closely packed arrangement of particles causes a solid to have a definite shape and volume. Are the particles in a solid completely motionless? No, not really. The particles vibrate, meaning that they move back and forth slightly. This motion is similar to a group of people running in place. The particles that make up a solid stay in about the same position, but they vibrate in place. Types of solids. In many solids, the particles form a regular, repeating pattern. These patterns create crystals. Solids that are made up of crystals are called crystalline solids. Salt, sugar, and snow are examples of crystalline solids. When a crystalline solid is heated, it melts at a specific temperature. In amorphous solids, the particles are not arranged in a regular pattern. Plastics, rubbers, and glass are amorphous solids. Unlike a crystalline solid, an amorphous solid does not melt at a distinct temperature. Instead, it may become softer and softer or change into another substance. Liquids. A liquid has a definite volume, but no shape of its own. Without a container, a liquid spreads into a wide, shallow puddle. Like a solid, however, a liquid does have a constant volume. If you gently tried to squeeze a water-filled plastic bag, for example, the water might change shape, but its volume would not decrease or increase. Suppose that you have 100 milliliters of milk in a pitcher. If you pour it into a tall glass, you still have 100 milliliters. The milk has the same volume no matter what shape its container has. Particles in a liquid. In general, the particles in a liquid are packed almost as closely as in a solid. However, the particles in a liquid move around one another freely. You can compare this movement to the way you might move a group of marbles around in your hand. In this comparison, the solid marbles serve as models for the particles of liquid. The marbles slide around one another but stay in contact. Because its particles are free to move, a liquid has no definite shape. However, it does have a definite volume. These freely moving particles allow a liquid to flow from place to place. For this reason, a liquid is called a fluid, meaning a substance that flows. Properties of liquids. One characteristic property of liquids is surface tension. Surface tension is the result of an inward pull among the molecules of a liquid that brings the molecules on the surface closer together. Perhaps you have noticed that the water forms droplets and can bead on many surfaces, such as the leaf shown in Figure 7. That's because water molecules attract one another strongly. These attractions cause molecules in the water surface to be pulled slightly toward the water molecules beneath the surface. Due to surface tension, the surface of Water can act like a sort of skin. For example, a sewing needle floats when you place it gently on the surface of a glass of water, but it quickly sinks if you push it below the surface. Surface tension enables the water strider in Figure 7 to walk on the calm surface of a pond. Another property of liquids is its viscosity. A liquid's resistance to flowing. A liquid's viscosity depends on the size and shape of its particles and the attractions between the particles. Some liquids flow more easily than others. Liquids have high viscosity, flow very slowly. Honey is an example of a liquid with a particularly high viscosity. Liquids with low viscosity flow quickly. Water and vinegar have relatively low viscosities. Gases. Like a liquid, a gas is a fluid. Unlike a liquid, however, a gas can change the volume very easily. If you put a gas in a closed container, the gas particles will either spread out or be squeezed together as they fill that container. Taking a deep breath, your chest expands and your lungs fill with air. Air is a mixture of gases that acts as one gas. When you breathe in, air moves from your mouth to your windpipe to your lungs. In each place, the air has a different shape. When you breathe out, the changes happen in reverse. What about the volume of the air? If you could see the particles that make up a gas, you would see them moving in all directions. The particles are no longer limited by the space in your body, so they move throughout the room. As they move, gas particles spread apart, filling all the space available. Thus, a gas has neither definite shape nor definite volume. You'll read more about the behavior of gases in section 3.